7.4 homework, transformations. So determine whether the dilations from polygon A to polygon B is an enlargement or a reduction, and find the scale factor. So we have two examples here. What I'm going to do is I'm going to refer back to the notes and tell you what you need to do. I'm not going to go through these problems whatsoever. I'm just going to refer back to the notes so you have an idea on what to do. So the first thing you need to do is you need to read the directions. It says you're going from polygon A to polygon B. Just like the notes, you're going to go from old to new and use that formula that we talked about in class or in the notes video. Remember, the scale factor is the ratio of the image to the original figure, and you're going to use that formula, new over old. So here what we did was we counted these two sides here, created a proportion, or not a proportion, sorry, you created a ratio, and then you're going to determine whether that scale factor that you have is an enlargement or a reduction. So the scale factor, the rule, or the rules, we have less than 1, that means that's a reduction, or if your scale factor is greater than 1, that's an enlargement. So once you figure that out, once you understand the notes, you're able to do these two problems here. Then number 3, just like this example here, graph the original figure and its dilated image, then verify the dilation is a similarity transformation. So are you using, or I'm sorry, is it side similarity? Is it side similar, or angle similarity? So you have your original points, and then this is your picture. I'm sorry that the original is not graphed for you, so you're going to have to graph the original this time. And then you're going to graph the image, and you're going to compare those two figures and see, are those two figures similar? What I would recommend that you do is do something like this. Compare two corresponding sides, create a ratio, and do that for the other side. Or not for the other side, more like the other, two corresponding sides. And then create a ratio, compare the two, and see if there's something else to prove that those two figures, once you draw them, are similar. Again, side similarity, side angle similar, or angle similarity. Now we got some vector problems, or more like translations here. So it says trapezoid JKLM with these points here, and you're going to use this to, you're going to read that, you're going to interpret that, and then transform these points. So I have x minus 7 comma y plus 1. So if I look at the notes, this x plus 5 and y plus 0, for the x's, since I have a plus 5, that means I'm going to the right 5. So if I have x minus 7, well, what does this minus 7 mean? Okay, and then for y plus 0, since I'm not going anywhere along the y-axis, well, that's why I have that plus 0 there. But for the homework problem here, we got y plus 1. So what does that plus 1 tell you to do? In fact, what are these both? What are these two things telling you to do? You got x minus 7, y plus 1. I'll let you figure that out on your own. Okay. Now we got the chevron vectors here. So remember, we got these little Benty brackets here. So the rule I got for the x, if you have a negative number, you're going to the left, or if you have a positive number, you're going to the right. For the y, you have, a positive and negative. So it means that if your number is positive, you're going up. If your number is negative, then you're going down. So what does positive 5 comma positive 2 mean to you? And then let's see. Okay, so we have another one of that. I'll let you figure that out on your own. 7, 8, 9. It's telling you to, or all these problems are telling you to reflect across a certain line. This one's saying across the y-axis. So ask yourself, does the x or the y change? You have across the line y equals x. Think y equals mx plus b. And then here you got, reflecting across the x-axis. Again, are you changing the x or are you changing the y? I highly recommend that you go back and look at your notes here.